Another integration question here. First thing we should notice is that the top limit of this integral is infinity. So that is a certain type of improper integral. How do we solve these? Pretend basically that the infinite symbol is not there to start, and we're going to just put a variable in there for now. Solve the integral as normal, and then we actually have to take the limit as that variable goes to infinity. Because we know we can't just plug in infinity, that doesn't really make sense. So what we're going to do is we're going to take that upper limit as an actual limit going to infinity. So it's going to look like this. I'm going to replace that with x for now, and I'm going to say we have the limit as x goes to infinity of this integral from 1 to x, 7 over t squared dt. Again, I haven't really changed anything here. I've just replaced infinity, which isn't a real value, with x. How do we solve this integral? We'll keep this limit outside until the end. And this is the integral from 1 to x of 7t to the negative 2 dt. It's probably easier to see it that way. Now we can just use our general polynomial formula of going up one power and dividing by that new power. So it's the limit as x goes to infinity of 7t to the negative 1, because that's 1 higher than negative 2, divided by negative 1. And we're going to evaluate this from t equals 1 to t equals x. Plug in the x and then plug in the negative 1. And we get 7x to the negative 1, so it's negative 7 over x by plugging in the x, minus negative 7 over 1. So minus negative 7. Again, I got these by plugging in the x term first, and then subtracting, plugging in the 1 term. This is equal to the limit as x goes to infinity of negative 7 over x plus 7. Now we can actually just apply our limit, and we know that anything with an x on the bottom, as that goes to infinity, that term's going to 0. So this just equals 0 plus 7. So the integral, the improper integral equals 7. That would also mean that this series would converge, but that's sort of a whole nother story. So that's how you solve improper integrals. When one of the limits is infinity, replace it with a variable, take the limit of that variable going to infinity, and then solve the integral as normal. Hope you found this helpful. You can always send us more questions, info@arnoldtutoring.com. Thanks.